Hello everybody and welcome to our second and last lesson in Unit 1 Characteristics of Functions. Today our objectives will be to analyze a graph to identify intervals on which the function is increasing and decreasing, identify the intercepts of a function presented graphically, and graph the inverse of a function as a reflection across the line y is equal to x, in other words, one of the diagonals. In order to be able to determine increasing and decreasing intervals, we need to first understand the concepts of local maximum and local minimum. A local maximum is a point higher than points around it. In other words, we are talking about something that looks almost like the top of a hill, the point which is at the top of the hill, and to both sides the points next to it are lower. A local minimum is a point lower than points around it. And here we can think of a valley. A valley with the lowest point being the local minimum, and the points around it on both sides are higher points. So then an increasing interval is a section of the graph where f of x increases as x increases. And I'm going to circle this word and you will see in a minute why. The decreasing interval is a section of the graph where f of x decreases as x increases. In other words, we're always thinking about x increasing, in other words, going from left to the right, but an increasing interval is where f of x, in other words, the y values also increase, while a decreasing interval is an interval where the y values decrease as x increases. When you think about f of x increasing, just think about the line that goes up from left to right. And when you think about f of x decreasing, think about a line that goes down from left to right. And then we have intercepts, and intercepts are a concept that are well known to you. The X-intercept is a point where the graph crosses the x-axis, and the Y-intercept is a point where the graph crosses the y-axis. Let's look at some examples. Let's look at an example on the left. A local maximum is a point that is higher than the points immediately around it. Here we can see two local maximums right here and right here. So those local maximums we put down as an ordered pair, and they will be -2, 3, and the other one is 1, 0. Let's see if we have a local minimum, and indeed we do. The local minimum is right here, the lowest point that has points immediately around it that are higher, and the coordinate of our local minimum are 0 and -3. The local maximums and the local minimum give us 3 points on the x-axis that are important for us to determine our intervals. And please note that for intervals, the way we describe them, we only use the x values to describe the intervals. And as you will see, we will also, for increasing and decreasing intervals, always use parentheses, even if we use interval notation, because the points, the actual borders of the intervals belong to both intervals. That's why we cannot use brackets as we do for domain and range. Okay, then let's look at our graph and find our increasing intervals. We have two. One is right here, and the other one is right here. So the first interval, as you can see indicated by the little arrow, starts from negative infinity and it goes all the way to -2. The second increasing interval starts at 0 and goes to +1. Since we have two of those, we need to again use our unity symbol, which you already know from geometry, and that indicates that we have two increasing intervals, and we have given those in interval notation. Let's look for decreasing intervals. There are also two of those. These are the two decreasing intervals indicated on the graph, and we use again our points that we marked on the x-axis to determine that the first decreasing interval starts at -2 and goes to 0. The second decreasing interval starts at +1 and, as indicated by the arrow, continues onwards to positive infinity. Combine these two by our unity symbol. Now let's find our x and y-intercepts. The x-intercepts are here, here, and here. In other words, the coordinates of our x-intercepts are -3, 0, -1, 0, and 1, 0. We only have one y-intercept. The y-intercept is down here. It's actually the same as our local minimum, and the coordinates of our y-intercept are 0, -3. Let's go to our second example. Looking for local maximums, we realize that there are none. The graph goes up in both directions as indicated by the arrows, but that does not mean that we have a maximum because, as you know, the graph keeps going. There is no maximum point. In other words, we just state none. We do see one local minimum, which is right here, and the coordinates of our local minimum are 0 and -2. Let's look for increasing intervals. A local minimum is also our point that we will put on the x-axis to help us find intervals. And from there we can see that there is an increasing interval, which is right here. The increasing interval goes from 0 to positive infinity. And we also have a decreasing interval. And the decreasing interval right here goes from negative infinity to 0. There are two x-intercepts. The x-intercepts have the coordinates -1 and 0, and the other one is +1 and 0. Our y-intercept is right here at the same spot as the local minimum. By the way, that doesn't always have to be the case, okay? In these two examples it is, but that doesn't necessarily have to be the case. Our y-intercept has the coordinates 0 and -2. Then let's go to our next example. Our local maximum is right here, and it has the coordinates -1 and 1. The open circle is not a local maximum because to its right it doesn't have points that are lower, so therefore it doesn't count. Our only local maximum that we have at this point or in this graph is the point -1 and 1. Our only local minimum is right here, and it has the coordinates 1, -1. And again, our closed circle also is not a local minimum for the same reasons as the open circle not being a local maximum. We do have these two marks on the x-axis to help us find our increasing and decreasing intervals. We do have two increasing intervals, this and this. And the coordinates of our increasing intervals are from -4 to -1. And the other one goes from +1 to +3. Don't forget your unity symbol in between these two. We have only one decreasing interval. The coordinates of the decreasing interval are from -1 to +1. Let's find our x-intercepts. These are our three x-intercepts. The first one has an x-coordinate of, I would say, around 2.5. Y-coordinates are, of course, 0. Second one has the coordinates 0 and 0. And the third one has the coordinates 2 and 0. Let's find our y-intercept. Our y-intercept is here also and has the coordinates 0 and 0 because our graph crosses at the origin. Whenever a graph crosses at the origin, that means that that's both an x-intercept and a y-intercept. Remember that. That makes life easier. So this ends the first part of this lesson, but please also watch the second video to finish your notes and finish the lesson.